Hello everyone, I'm Xiaogang. In this lesson, we'll write our component, and then the component we reserved in advance. We'll put the name of this component in. First, we have this equipment, meaning our backpack component, which we call inventor warehouse. Then we also have an equipment component called equipment. We won't write this equipment for now, not yet. We'll write it later, because it's quite complicated. Because our backpack is still under drag and drop, let's first ensure it works. We can definitely do it all at once. Paste all the header files in for you, but then when you write, I can finish writing all the C++ in one go. Then you can go and look at it. Then you definitely curse me out, right? Because when I was writing it, I didn't finish it all in one go. Look at you. When recording the tutorial, I can't present it to everyone like this, but this way is much faster. And this is the forward declaration. Nothing much to say about it. Then, just include this header file in the source file. Okay, so these are some things we might need. This is what we'll be using. So first, how do we do it? Actually, this backpack is essentially a CRUD operation on a container. This is also quite simple. So first, let's define a struct. This struct is for this single slot inside our backpack. It specifically describes an entity within the backpack. When we do it, we must separate our presentation layer from our data layer. Otherwise, if we mix them together, it will be very troublesome. This points to our specific asset. This points to the quantity of the asset. This is our asset. Then here we determine whether this thing is usable or not. And then we essentially clear it. That's roughly what it means. Next, we'll write out their implementation. Okay. There are still some red errors here. We'll ignore them. Then in its constructor, we first need to reset this value to 0. Then we set this value to a null pointer. That is, by default, it is empty. And when is it usable? As long as this quantity is greater than 1, we consider it usable. And the asset we are pointing to exists. Right. Then how do we make it release itself? We just take this pointer that is pointing to, we remove this pointer, because for something like an asset, we generally just keep it in memory. Since we are not dealing with memory optimization yet, for assets like this, we have a few pieces of equipment. We directly load them into memory. Okay, so this is how we describe a piece of data in the backpack. We use it to describe it. Then here we are going to prepare this should be a single wave, right? Prepare this. It should be a single wave. And then it means that when our warehouse changes, we will take all these things in our warehouse. Trigger this delegate. Let everyone else know that our place has this. The backpack has changed. Let's compile it first, and then handle this red line for everyone. Otherwise, it looks a bit uncomfortable. This must be written this way. That is, if you are a book owner, you must write it this way. Otherwise, if you don't write it this way, it may not compile. Okay, we'll refresh the line here. This way, there won't be any red lines. Okay, now let's write our component. This component is just a logic component. We'll have it inherit from our Kanban base. We'll have it inherit from Kanban base, even though we haven't written anything in Kanban base yet. We'll add things later. That is, for things like our flay, we can write many methods. Okay. So we need to execute it. After executing it, first we need to prepare a constructor. Prepare a constructor. Inside this constructor, actually, we have a lot of work to do. We give it a super. And then here, we need to create our container. As for this container, we give it a variable, or this variable, and it must be synchronized over the network. That is to say, this thing, it must be synchronized over the network. So here we need to write this method. Okay. Then we also need to write this delegate. As for this delegate, we put it above, pass it in a more forward position. We won't bind it directly to blueprint here because we plan to write our UI in C++. That means we won't make it dynamic here. So this approach is considered. Then we have a method like this. We'll put it here too. Put it here. Okay. Next, let's create the implementations for these methods. Good. When we have such a variable, we need to, because it needs to do this synchronization. So we have to mark this thing. And since this involves networking, we need to include the header file. All right, I'll write this header file all at once. First of all, we definitely need to use this. Light work. Only then can we register the synchronized property variable. Next, we need to use equipment. We definitely need to include it, and then some other things we commonly use, like a gaming capability and so on. As for this component, we also need to include it, because we will use this view component later. Okay, now it won't report errors. Next, regarding this, that is, when we receive the synchronization on the client, we need to do the corresponding work here. So we just need to swap this proxy out, then pass this over. Then the UI side will know. Because once the client starts, it will essentially update its value. Right. Because this value will be continuously sync from the server. So here we have completed this sync update because we are doing this. So in the constructor, we also need to enable some related sync settings. First of all, we definitely need to turn off tick because we don't need tick anymore. Okay. Then here we are at this point. We plan to make 30 of them. So we call it add default. Default will add the default one. Right. And here our constructor should be given this because our constructor has parameters. Hey, we're standing in the wrong place. It should be here. We're standing in front of that struct. It should be right here. Okay. Then here we enable the sync default. Enabled. Okay. Okay, so in this way, our backpack, it has a default capacity of 30. And actually, this synchronization, doing it this way is actually quite good. And if you want to optimize it, you can take a look at Unreal Engine. What we are talking about now is the most basic network synchronization. It also has some Aries and also Aries and things like FastRelay, specifically designed for network synchronization. This can save bandwidth because sending it every time like this, you might send a host like this every time. Actually, its synchronization amount is actually quite high, okay? Like this, we have basically prepared our container. After preparing the container, we need to start writing these methods inside. First of all, let's fill in these few methods. Let's fill in the begin play. Fill it in at this position. Paste it. Because you might need it sometimes. We won't write this tick because we don't use tick. Okay. Okay, then let's start writing the CRUD methods. I'll just paste this part directly for everyone to write. And let's make this method protected because for the CRUD operations on this inventory component, we must base it on the server. So I don't really want to turn it into an RPC method inside this component. That would be very troublesome to call. We'll write only RPCs on the character class. So we'll write it like this. First, let's add. And then here we'll give the specific thing to add. Then we will determine whether it can be added successfully. If you encounter a situation where this first party is no longer occupied, then you cannot add it successfully. We can also go to a specified location and add it to the specified location. That is if we simply overwrite it. Sometimes we may have special handling for this situation. This is not exposed to Blueprint. It may be used less often. Then we can also remove the specified location. Here, you only need to pass an index. We can just remove it. Then we can also, that is, this removes a specified quantity at a specified position. That's what this function means. Then we can also swap two positions. Okay. So that's about it. Actually, we can also check whether the current inventory component has methods like checking for a specific item. Let's just write this much for now. Then we can give it this. This gets the position of a specified item in the warehouse. You just give it an index, and we need to change this part. We need to remove this RPC because I need several methods. Let me think. I cannot write RPC here. Okay, these methods can all be exposed to Blueprint as well. Actually, let's make this method into BeginPlay. Instead of that public one, but we need to be careful when calling it. Then we write another one. These methods can be added according to your own needs. What is returned here is what specific type of asset this is. This will also include the quantity of that asset. Then let's write them one by one from the beginning. The first method is to add. First, we must be on the server to be able to perform related work. So first we get our owner. It must have this authority. Only then is it acceptable. Actually, you can see that we wrote it like this here. Actually, we can see our class. We are here, following it here. It actually has such a method, which is hide authority. Actually, it's the same here. Actually, we can call this method. This way, it looks cleaner and clearer. So, going back, we just give it this method. Okay, after it collapses, that is to say, we first need to determine whether this newly imported item is valid, because we are unlikely to add an empty one. So if it is not valid, we should give a prompt here. Then we need to find whether our original repository already has this item. If it does have this item, then what does that prove? It proves that we increment the quantity by 1. If it does not have it, only then do we add it. So we can just do it this way. Okay, if you look at this place, we iterate here over what we currently have. Then after we iterate a negative loop, if this thing true and its quantity can be greater than 1, then we just add it here. Then after we modify this, we actually don't really need to manually notify the UI because we do it through property synchronization. We return at this point. This means we are done processing. If we look for the original warehouse here, if it doesn't exist, right, that is, if we don't have it, we will go now. We should give it a define here. This means we have found it. So if we didn't have it originally, we will check if there is an empty slot. That is, we must have an empty slot. If there is no empty slot, we consider it a failure. So how do we find it? Now, we start a for loop again, but you can optimize it. We didn't optimize this part. Then you can look for it like this. If this spot here is empty, then we just occupy this position. That's roughly how it's done. Actually, it's determining here whether this original position is empty or not. Actually, we can use this because we wrote this method. This way is also fine. Okay, and if all of the above fails, it means our warehouse is full, so we give a return force. You could add a log, a prompt, or something. We didn't write one here. So this is a simple logic for adding. Next is to directly replace this position without considering what it was originally like. So we just replace it right here. Actually, we still need to check here whether it's out of bounds or something. That is, if it goes out of bounds, it might crash or something. We won't worry about that on our end. Everyone can add it later. You can also write a method. That is, when removing this English tour. At the same time, generate this object in the scene. This is equivalent to you had picking before. Picking means you pick an object in the scene. Then an object in the scene disappears. Then add such an item to your backpack. Throwing it out means first in the backpack. Remove it, then generate it in the scene. This part is to swap the specified position. And this is to directly remove it. That is just clear the current position. Then we directly call this inventory. Just reset it off. Okay. Next is this. Remove the specified element because you might not know this thing. It is what exactly it is. Then we directly give it a loop. Okay, then here you can specify how many elements it has. Right, then we directly do an addition and subtraction of the quantity. If after subtraction the quantity is less than 0, we just reset it off. This is equivalent to what you pass in. First, compare the types. That is, check whether they point to the same asset. If so, we will subtract 1 from the quantity of that asset. That's it. Okay, next is the swap. Swap two positions. This is used more often because sometimes we may need to, when dragging, we need to handle it this way. But since we can directly call our swap function, it's fine. Okay. Here, we might also need to retrieve something. The reason for the error here is that if we add function, we are not allowed to do things like overloading these methods. Let's take a look at the error here. This should be not that the name should be different. Let's just look at what the cause of the error is. The reason for the error here is that it does not allow you to return a pointer to a struct. This is also incorrect because you added the function here. Right. Then it makes this thing perform a copy. Okay, after we finish writing here, let's get their implementation done. That is, we need to get the specified item, then we can just take it from here. We'll access it directly. There's no out-of-bounds protection here. Just let it crash. If it crashes, it definitely means we have an out-of-bounds issue somewhere. Somewhere the parameters passed are not quite right. And here we just take this thing and copy it out. Once you copy it out, this thing can no longer be modified. It is only moved out as a piece of data for reading and writing. Okay, physically, our repository is written like this. Let's compile it. Make sure it compiles successfully. Okay, it doesn't compile here. Let's take a look here. Hydra30 here has actually already made a judgment. So we shouldn't be doing it this way here. We can just do it here. Click it. Okay, actually regarding this thing, all subsequent modifications to this thing should be allowed only on the server. So here, we'll add them all anyway. If that's the case, we'll do it like this. By default, we'll give it a force. Okay. Here, we'll also add a judgment. Okay, it's easy to make mistakes when adding things here. So everyone, please pay attention. Here, we'll have it return a null pointer by default. This part should be controlled like this. That's fine. This part should be the same. If this part is on the server, actually this part is not certain because it's possible for the client to get this thing. That is also possible. As for this, for things like this that we access individually, we should not add this permission check. We'll take the individually accessed part here and delete it. If it is accessed individually, we don't need to add this permission check. Only when we are involved in modifying this data, we must add this permission so that it cannot modify this data on the client side. Now let's add a method. Let's add one to check whether it meets such a condition. Let's add one. Then we set it to pure here. Okay. Then we create its property. Then we return false by default. We still need to give it a for loop. Let's just do a for loop like this. Then during this for loop, we check. That is, if its inventory size the thing that pops in here and this thing inside it are the same. And their quantity is also consistent. It should be this. The icon should also be consistent. Then we consider that it has such a situation. Okay, there is an error here. Let's check what the cause of this error is. This usually uses an equality operator, not an assignment. Sometimes we make mistakes when writing. Then pick this one and press enter. Good, then we have taken it. Let's compile it again. So in this lesson, we will mainly finish building this component. After this component is done, we need to think about where E is appropriate to intensely eat. Let's take a look. There must be a return value here, right? Let's give it a go. Obviously, this backpack thing would be better placed in the player state. Because, why? Because if your character dies, right? If your character dies, then the items in your backpack should not be dropped. But we still put them into our character. Put them into our character. Put them. We will uniformly place them here. Then, if you put them here, there will be a problem. That is, your UI actually performs this binding. During the first construction, it is bound to this actor on this inventory component. But if this object is destroyed, then this thing will obviously need to be bound again. Just like when we bind the health bar and the mana bar for health and mana values, there will be such a problem. So just be aware of it. We'll write it here, because we have a lot of things written here now. Okay, then we'll take it, paste it over, and put it here. And then it becomes our inventory component. Then, after we have this method, we need to provide it with a method to retrieve it. Actually, we haven't finished writing this yet, because this life still has one of its most important functions, called use. We'll write about this use function later, because it involves an RPC process. Okay. Then after such a component, we need to create it in the constructor and here. And here, change this part. Okay, then we need to include, it's best to include this file. Here, it should be this. Okay, let's compile again. Okay, let's stop here for now. Mingpo, Canada, Mingpo, Toronto.